This is the Year 8 Metals and Acids Reverse the Classroom. Okay, so again, right, the idea is to go through certain bits of information so that when you're actually studying it in class, what you've then is you've got a bit of more of an idea about what is then going on. This is our snaky diagram. So what we've got physical and chemical properties, equations and gas tests, reactivity series, metals and oxygen, displacement, extracting metals using carbon, right, electrolysis, right. Now what I'm going to do is I'm just going to kind of go through very briefly the different topics that are then on the snaky diagram. And then obviously in class what you'll do is them in more detail. First little test, I'm just going to do one of these tests, is the test for hydrogen. If you've got hydrogen gas in a boiling tube, you put a lit splint into the boiling tube. What you do is you get a squeaky pop. That is then the test for hydrogen. The reactivity series, right, what we've got here is we've got a mnemonic to try and remember the reactivity series, which is please stop calling me a cute zebra in chemistry study groups. Now there's all sorts of different ones you can get. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, copper, silver and gold. Right, so what we've got there is we've got a very brief mnemonic. Now there's loads of other elements that can be on it, but it just helps you then to remember the order. Now on this, they're all metals except for carbon, and what you have to do is you have to have a pretty good idea about what's below carbon and what's above carbon, and I'll talk about that in a minute. Now there's also something called a displacement reaction, which uses that reactivity series that we had before. Right, what it's doing is it's saying, is there going to be a reaction? And it's all based on which metals are the most reactive. Now I'm not going to fill this whole thing in, but if I've got magnesium metal and I react it with zinc sulfate, what happens is there's kind of like a fight between the magnesium and the zinc. I then go back to my reactivity series, and whichever one is the highest in the reactivity series wins the fight. So for this one, because magnesium is higher than zinc sulfate, there will be a reaction, and what we'd end up doing is we'd get magnesium sulfate and then zinc could be on its own. This next one along here, magnesium and iron, if I look at my reactivity series, so here I can also write a Y, there will be a reaction. Last one I'm going to do, right, I'm not going to complete this whole table, magnesium and calcium. If you look at the reactivity series this time, calcium is more reactive. So therefore magnesium and calcium kind of have a fight, calcium wins. So there is no reaction because magnesium can't displace the calcium. An ore. An ore is a rock that contains enough metal to make it economically viable to extract. Right, there's my rock. Right, if I then had to spend £1,000 extracting the metal, and the metal was only worth £400, it's not financially viable to do. So an ore is a rock where you extract the metal and you actually make profit from it. That is an ore. Extraction of unreactive metals. Now we talked a little bit then about reactivity series, but there's a couple of metals like silver and gold that are so unbelievably unreactive that you can just find them in the ground. So you can dig them out of the ground, right? Dig them out of a rock if you know where to find them, and you can then remove the silver and gold. Those ones that are a little bit more reactive, what you can do is you can extract them using carbon. Now again, think about the reactivity series. All the ones above carbon you cannot extract with carbon. All the ones below carbon you can extract with carbon. And it is that displacement reaction that I talked about before on that table, where what you have is you have a metal oxide and carbon, and you'll make metal and carbon dioxide. Lead oxide is a metal and an oxide, heat it with carbon and I make lead and carbon dioxide. In symbol form, I've got lead oxide, react it with carbon. Now because carbon is further up the reactivity series, it displaces the lead, so lead then is on its own, and I make carbon dioxide. Now if they're above carbon in the reactivity series, to actually extract the metals we have to use electrolysis. Now that is as far as I'm going to go with this, because with electrolysis it's actually quite a complicated system, But in a nutshell, right, what electrolysis is, it's the extraction of metals above carbon using electricity. Questions. Right, we've got 4 questions. Number 1, what is an ore? I want a sentence. Number 2, what is the test for hydrogen? I want a sentence. List the metals that can be displaced by carbon. I want a list. What is electrolysis? I talked definition then, and I want to write that definition down. All right, so what we've got in there, the vast majority of that unit is all about displacement. Okay, you need to then, if you don't understand what I mean by displacement, you need to go back and then you need to have a good look and try and understand exactly what displacement means.